General relativity, step by step. I've got this nice set of equations here for representing the stress-energy tensor of a perfect fluid in a coordinate system in which it's not necessarily at rest. And I've got this nice expression for t bar 0, 0 here. Gamma squared, in fact I'm going to write it out here, gamma squared rho plus pu squared. Gamma squared rho plus pu squared. Gamma squared rho plus pu squared. Now, when I was working, the other way I got of expressing it was the stress-energy tensor was with this rho plus p, this formula u alpha u beta plus p g alpha beta. And that gave me this transformation rule here. Now, if we've got two ways of working out the same thing, they should be the same. And they don't look the same. This is rho gamma squared plus p gamma squared minus 1. I'm going to write that down there. If I can find it. Rho gamma squared plus p gamma squared minus 1. So we've got two expressions here which look very different. One's got a u squared in it, and this one hasn't. And it tripped me up for a very, very long time because they should be the same thing, and they apparently are not. So what I'm going to do is I'm going to form d for the difference, which is gamma squared rho plus gamma squared pu squared minus this thing, rho gamma squared minus p gamma squared minus 1. And when I'm forming the difference should be equal to 0. So I can do some cancelling here. That's nice. Back to black. Find it. There. So pinch in a little bit. And so that equals p into gamma squared u squared minus gamma squared plus 1. Which again looks crazy, but then you remind yourself that gamma equals 1 over root 1 minus u squared. So we can substitute for that, equals p into u squared over 1 minus u squared minus 1 over 1 minus u squared plus 1. And then we do some factorising, p equals 1 minus u squared minus 1 plus 1 equals p minus 1 plus 1 equals 0. So the difference is 0, and the transformation makes sense. I've done the same transformation in two different ways and got the same answer, although it's not obvious that they are the same answer. They are, because everything cancels out. Oops. Where was I? Where was I? I was here, wasn't I? I was here. Everything cancels out, and the universe makes sense again. That tripped me up for quite a long time. I spent quite a long time pondering this before I actually realised that you should take the difference of the two. My thinking was that when you look at the two terms, that this has got a u squared term in it and this one hasn't, so they must be different. But it's easy to forget that there's a functional relationship between gamma and u. Well, this one here. And it's easy to forget that the two things are interrelated, and when you remember that, everything makes sense again. And the two expressions are the same. And you can do the same thing for the other terms in the equations as well. So I'm going to stop there. Stop.